Good morning, students. Today we will see the power distribution, power optimization and interconnect routing techniques from unit number 2. Unit number 2 is associated with system on chip. Whenever you are putting the different components on a system or on a chip, then there are issues related to the clock which we have seen earlier. In today's lecture we will see that how is power is being handled in the system on chip. Power distribution is one of the important thing whenever you consider a chip. In most of the cases, the power rails are mainly made up of metals, and the distribution networks which runs both VDD and VSS, that is VDD and ground, this routing is done in metal. Whenever you route these VDD as well as VSS, the size of the wire should be sufficient to handle the required currents inside your IC. Also, the transient behavior of power distribution network that should not cause a problem for a logic to which the current is being supplied. Hence, whenever you go for a designing of a chip, it is essential that you should consider power distribution, because whenever you fabricate a wire on a chip, the IR drops will also be over there, as well as because of fabrication of wire there will be definitely LdI by dt, that is inductance drop, which may be arises due to the transient currents. To solve this, there are certain power distribution techniques which are being considered while designing a chip. The power network is being designed as shown in this figure. You can see in this figure a certain arrangement has been made through which the power as well as VDD is routed throughout the chip. And if you have a multi-layered structure, still you have to go for a floor plan, and that floor plan should isolate the ground pins also. This is essential whenever you go for a power distribution. This power distribution is important so that there will be an even distribution of power throughout the chip. There are different techniques of power distribution, in that you can have a power distribution grid also, and in case of large chips, power is distributed using several metal layers also, and the upper layer are larger in width as well as height. The layer closer to the silicon are smaller in both the dimensions, and global power distribution happens on the upper layer connection. On the lower layers move the power down to the circuit. Now, power optimization. Whenever you are designing any circuit, you must think of how we can optimize the power on your system. this is the same thing, that you are designing a circuit or you are partitioning a circuit in such a way that your power dissipation is as low as possible. That's why in power optimization you should able to avoid the glitches which are coming from the circuits. If you want to do a power optimization, this power optimization will be done to reduce the power consumption and to make it change its output as few times as possible, that there will be a very less changes as possible, and the number of unnecessary changes to the gate output should be reduced to have a better power optimization. There is an example that how a glitch will transfer through a circuit and will cause a power dissipation in your circuit. The circuit in the figure shows one NAND gate and one NOR gate. Here these two inputs are fed with 0, whereas the third input is also fed with 0. In a NAND gate, when these two are 0, its output is 1. This output is 1. And in case of OR gate, actually it is a NOR gate. This is a NOR gate, and if any input is 1, the output is 0. But what happened in this circuit? These two inputs are 0. The output is supposed to be 1, but because of gate delay of NAND gate, the output become 1 after a certain time. Because of this, for this much small period, both the input to this NOR gate is 0 0, which cause the output to become 1 for the time period of the propagation delay of this gate. This is what we got in the output, a little high value in the output. It is unnecessary, or you may say that it is a glitch in the output which is not required as 1, and this switching from 0 to 1 or 1 to 0 will cause a more power dissipation. That's why if in your circuit, if you know that which input has more or which will go for more glitches, then you can have a better rearrangement of your design. For example, you can see that here this is just an arrangement or a schematic to eliminate a glitch. At the end, whatever the output you are going to see over here, this output is going to add A plus B plus C plus D. Such a 4 input it is going to add. In this figure also it is going to add a 4 input. But suppose that if A has more glitches, then quite obvious, in this case it is going to travel with these 4 adders or 4 adder circuits, and it will be a more glitch prone. Here you can see in this also you are getting the output as A plus B plus C plus D, but if A has more glitches, then it is going to travel only through 2 adders, and it will give you a better elimination of glitches. Now next topic, that is interconnect routing techniques. What is actually the interconnect routing technique is over there? Whenever you fabricate any IC, inside the IC you have to connect different components or different sections of your IC, and these are connected through the wires, or you may say a metal paths. For this you have a two different types of interconnect routing. It is a global routing and detailed routing. The global routing assigns wire to the routing channels between the blocks, and detailed routing designs the layout for the wiring. Global routing uses routing algorithms, and it will use a line probe routing for routing all the wires throughout the chip. There is another method of routing also, that is a switch box routing. Actually, switch box may be used to route wires between intersecting channels. Whenever we will study the FPGA architecture, at that time we will come to know that what is this channels is over there. Actually, it is the intersection of two different you may say connections. Okay, and track the assignment at the end of the channel to define the pins for switch box. Here you can see that there are these two channels, and these two channels are being overlapped over there, this particular portion, and the switch box routing or the connection will be done inside this. Thank you very much.